In section 3.4, we're going to look at how to name these ionic compounds that we've been looking at. So if you're in the main group, cations, groups 1 through 3A, you're going to just name them for whatever their element name is. Simple as that. So Na plus is sodium, potassium, calcium is Ca2 plus, magnesium is Mg2 plus. Remember, we know where those charges come from by what column or group number they are. So sodium's in group 1A, that's why it's a +1. Calcium, magnesium are in group 2A, that's why they're +2. But they're still just called calcium, okay? When a metal is able to form more than one cation, then you have to use a little different nomenclature. The systematic names, which are the ones we use, okay, are using a Roman numeral to tell someone what the charge is. So for example, iron, Fe, can either be a +2 charge or a +3 charge. So we would have to say, if we're naming that it's iron, Roman numeral 2 in parentheses, versus iron, Roman numeral 3 in parentheses, so that whoever is looking at drawing a formula from that or whatever knows which one it is. Okay, and it's also going to be critical in how many anions are going to have to attach to that iron, depending on whether it's a +2 or a +3. The common names use the OUS suffix and the IC suffix. And so the IC is the smaller, okay? IC is going to be the higher charge, however. So US is the +2 iron, IC would be the +3 iron. And I'm telling you this because you will see this written sometimes, because this is the common way of saying it. But in chemistry class, we're going to always use that systematic naming system. And so this is just a table to show you the different ones. Chromium, that's a common one that you see. It can be a +2 or a +3. That would be chromium 2, chromium 3, iron 3, iron 2, etc. So that's just how these things are going to be named. So when you're practicing these, you're going to be able to go back and forth and look at things. If there are some names that you especially have problems with, then you can write that on your index card for your test. 10 is one, and I'll tell you, 10, it's SN is the abbreviation for that. And I remember sin sounds like 10, or 10 sounds like sin. And so that's how I remember that SN is the way you do the 10. Okay. One thing about, I'll share with you about 10, stannous, okay. You will see that word. If you don't remember, it's on toothpaste, and they call it stannous fluoride. Okay, and so that means you've actually got 10 in that. Anions are named by just replacing the name of the element, dropping the suffix, and adding IDE. So for example, bromine becomes bromide. Chlorine becomes chloride. Nitrogen becomes nitride. Oxygen, oxide, okay? Phosphide, sulfide. So when you get down to these, the chlorines are easy because you just, ene goes to ide. But like nitrogen, oxygen, phosphorus, sulfide, they're going to form from that first prefix of the name. So nitride, oxide, phosphide, sulfide. Okay? Now when we put these together to name a compound, we're always going to name the metal first, okay, or the cation, which is the metal, first. You don't have to specify the charge on the ion unless it's one with a variable charge. How do you know? Well, if it's in those transition metals, a lot of times it's going to be one of those with the variable charge. But if it's in those main groups, 1, 2, 3A and 5, 6, 7A, then you're not going to have to, well, just the metals is all you got to worry about for this part. But you don't have to worry about giving Roman numerals. And you only do Roman numerals for the metals, okay? They're the ones that can vary in charge because the others are the nonmetals, the anions, and they're just going to, they are what they are. Okay, so sodium and fluoride, so you got a sodium ion and a fluoride ion becomes sodium fluoride. Magnesium and chloride become magnesium chloride, okay? And remember that our formula has got 2 chlorines in it because this is only a -1 and it has to come out to the 0, so you have to have -1 times 2, so that would give you 0, and so that's why that's MgCl2. So if you're going to name the compound that has a variable charge, what you can do is you're given the formula, okay, because you're just naming that formula. So you've got to determine what the charge is on that cation first. So what you do is you look at the formula, all right, and you say, okay, what do I know is always the charge? You always know that chloride has a -1 charge, because it's one of the main group ions. All right, you have 2 of those, okay? You have 2 -1 charges due to that chloride. So that's a -2 total charge. In order to have a 0 charge, you have to have what? A +2 on the copper. Since you only have 1 copper, then the whole copper has to be a +2. Okay, so if the whole copper is a +2, how do we tell anyone else what the charge is on that? We say copper 2 and then chloride. Okay, so copper 2, chloride. Okay. How do you write the formula from the name? Well, to me this is easier because you just go backwards, of course, but you are given what the charge is on that 10. It's a +4. That's what that Roman numeral means. So you have a +4, 10. Oxygen is always a -2. Now, how do you know what to do in this case? Well, you know that you have to have 2 times 2 to equal 4. So you have to have 2 times a -2 to equal a -4 because you need a -4 to add to the +4 to give you a 0. Yes? Okay. Now, let me show you that 10, 4 again. So you've got 10, 4 chloride. All right. And then we'll do 10, 4 oxide. We'll do 2 of these. Okay. All right, so 10, 4 chloride. So I have a -1 on my chloride, and I have a +4 on my 10. So I've got a 10 that's a +4, and a chloride that's a -1. Now, +4 and -1. What I do is called swap and drop. Okay, swap and drop. So I take whatever my charge is for this one and I put it down here. And I take whatever my charge is for that one and I put it down there. So what that makes is SN1, and remember we don't write ones, Cl4. That's from the swap and drop. Okay, pretty simple. All right, so let's look at tin 4 oxide. On tin 4 oxide, I have SN plus 4 again, because that's what the Roman numeral 4 tells me. And I have oxygen. And oxygen is in the 6A row, which is, which is what? A -2. So normally I'd say, okay, so 2 times that and all that good stuff, right? Okay. Let's just say, let's do the swap and drop on it. So I've got a 2 here. So the 2 would go here. The 4 would go there. All right. But I have to, if I get something that will divide by a number, then I've got to just reduce it. So instead of SN2O4, it would just be SNO2. This is just an alternative way of writing these, doing the swap and drop. Okay, the only thing, and it works every time. Okay, I'll tell you where this is nice. If you have an Fe, let's say, let me write the name, iron 3 oxide. Okay, so that means I have a +3 iron and oxygen has a -2. So I'm going to have to say, okay, well, I'd have to multiply that one by, this one by, and all that good stuff. Or I swap and drop. The 2 goes here, and the 3 goes there. So it's Fe2O3. Done. So that's why I like this one, because it's a lot easier and a lot simpler if you get into any that are complicated.